Hi, welcome to Train Signal. We're continuing our Advanced Services course with IP address management. This lesson is going to focus on an exciting new feature of Windows Server 2012 designed to take a tedious, time-consuming, error-prone part of your network management and making it much more elegant to manage. And here's how. The challenge is IP management. We've got lots of computers, they all need IP addresses. We need to have some degree of discipline as to which computers have which IP addresses. Clients get these addresses, servers get those addresses, that sort of thing. The question is, how do we manage that? Well, Windows has never provided us with a formal strategy for that. We could build a DHCP scope, but that was kind of all off by itself. There was no centralized place to keep track of how many DHCP servers I had and which ranges of addresses were being handed out by which and were they overlapping in any way, things of that sort. So, to address that challenge, Microsoft is preparing to roll out a technique that will allow us to move beyond those older challenges. Challenges of trying to decide, do I do manual static assignment of addresses or use DHCP? But if I use DHCP, how do I keep track of what's where? Am I going to document it with some Excel spreadsheet or an Access database or paper on a clipboard? Or just throw my hands up and say, I'm not going to document this. We're just going to let the chips fall where they may and fix IP address conflicts as they show up. That's not a terribly good approach. I don't recommend that one. But even if we chose to carefully document our system with some sort of paperwork somewhere, now we're going to keep track of the paperwork. Where are we going to keep the information that describes what we're doing? Microsoft decided to build a solution to be able to help address that, and it's called IP address management. And what it does is it provides a database-driven solution to store information about exactly how we're using IP addressing throughout our organization, being able to look at the macro scale all the way down to individual reservations for addresses on particular DHCP servers. We can analyze information about our DNS services and see which servers are doing what and where, and which zones are being deployed from what locations. I can audit all that behavior. I can do forensic analysis of who had which IP address on what date and time. That's very, very handy in many cases. So this is a very, very handy technique. We're going to start by looking at the installation of the tool, and then we'll segue into the first major task of the IPAM environment, which is to discover which servers are out there that we're going to be able to manage. It's going to query Active Directory and retrieve the list of DNS servers and DHCP servers that we're going to manage. So let me flip over to the server environment, and we'll actually do the installation. We'll actually verify that we can get this thing installed and get it up and running. So for reference purposes, here's Server 1. Server 1, you'll recall, is designed to provide me with DNS, DHCP functionality. You can see in my Server Manager tool that I've got a DNS and a DHCP node. What I want to do is I want to be able to manage that DNS and DHCP server, and although in my network environment here I've only got just the one, I'd like you to imagine that there's a dozen other DNS and DHCP servers out there. How do I keep track of all that information? Well, I'm going to need a database of some sort for this, and it turns out IPAM provides one. And what I'm going to do is I'm going to do all that work from Server 2. So let me flip gears. I'm going to jump over to Server 2 and look at things from its perspective. So here I am on Server 2. I want to be able to start IPAM installation. Like most features of Windows, we're going to deploy it from inside of the Server Manager utility. IPAM is what's referred to as a Windows feature. Microsoft categorizes the components of the OS that you can deploy as either roles or features. DNS server is a role, Hyper-V is a role, Windows Deployment Services is a role. IPAM is a feature. Roles in general are things that you might dedicate a whole server to. I might deploy a whole server just because I want to make it a remote desktop services server. This is the feature formerly known as terminal services. Features, not so much. I probably wouldn't deploy a whole server for that purpose. In this case, there is a requirement of IPAM that I do need to put IPAM on a server that is not a domain controller. Right at the moment, Server 1 is a DC, so I can't put it there. So I'm going to do role and feature installation on Server 2. Wants to know which server. That's this one. I don't have a role that I want to install. What I want to install is a feature. IP address management is there. As soon as I check it, it wants to turn on a number of other important features, including some features of the .NET Framework to be able to do the communication between the servers. Support for remote server management. I want to be able to reach out and connect to the IPAM server. Now it's going to be on the same computer, but importantly, I can reach out to an IPAM server from a remote destination. And indeed, you might well want to focus on that as part of your exam prep, those of you heading towards a Windows Server 2012 certification. So we're going to deploy the Windows Internal Database. This is a feature formerly known as SQL Server Express Edition. Microsoft rechristened it back with Windows Server 2008, and it became the Windows Internal Database instead. Windows Process Activation Service is part of IIS's internal behavior for managing multiple executables that are able to operate independently of each other. In any event, all those things are going to be installed behind the scenes as we go to install this feature. And I'll click Install to start the installation, and that'll take just a moment. So there we go, we've successfully installed the feature. As I click Close, we'll see that my Server Manager has updated to include now an IPAM node over here off to the left. Clicking it brings up a list of setup tasks. What's referred to as the Quick Start feature of Server Manager gives most of the components that I've got available to me in Server Manager the ability to start the configuration process with a logical, not exactly wizard-driven, but almost, maybe even a series of wizards, but a automated process. We can see that I've developed a connection to my IPAM server. Importantly, this whole interface will not appear if you've not installed the IPAM client on this computer. Now, it doesn't mean that I have to have the client here. I could have the client over on some other computer. I could put it on my Windows 8 machine. That would be a logical thing to do. But in this case, we've got it here on the server. That's fine. So we've already connected to the server. Step 2 is called provisioning. Step 2 basically is answering the question, how do I want to manage which computers are going to be under the influence of IPAM? And the starting point for that is a simple decision of whether I want to manually configure that or automate it. And in general, the automated group policy based approach is the more logical one. Here's the basic story. IPAM is going to be reaching out using its software and connecting into DHCP servers, connecting into DNS servers, connecting into domain controllers, connecting into network policy servers, and gathering information about what it finds there. And it's going to centralize that information in this central IPAM database here. In order to do that, this computer needs to have permission to get into those computers. So that's going to require, at the very least, firewall rules to be able to let these requests get in past the local Windows firewall on those servers. It'll need group membership configurations. My DHCP servers have a DHCP users group that provides access to retrieve information. To be able to make IPAM work, I need to put IPAM's computer account inside of that group. So these kinds of changes need to happen somehow or other. And I could do it manually. I could go visit each computer, configure the shared folders that are needed to gain access, configure the security groups, configure, as it's pointing out here in my wizard, firewall rules. But that is an awful lot of work just to be able to gain access to those servers. But it's a feasible approach. It can be done. Microsoft provides a lengthy list of which firewall rules need to be put into place, those sorts of things. That can all be automated through group policy, which is an eminently sensible thing to do. In order to do that, it's necessary to be able to build a set of 3 group policy objects. And again, IPAM is going to do this work for us, which is wonderful. What we need to do is to identify the prefix, a set of initial characters that will uniquely identify these GPOs as unique to this IPAM process for Globomantics. So I'm going to put in a GLBM, Globomantics, prefix. In order to get this to work, we do need to create that set of GPOs. And note that the note here at the bottom of the screen says we're going to create those GPOs in the invocation of a PowerShell commandlet, invoke-IPAM GPO provisioning, the launching of which is going to actually go ahead and build the GPOs in the Group Policy Management console. It's really rather cool. If I click Next, we'll see that it's preparing to create 3 GPOs. Those GPOs all start with GLBM, Globomantics, as I requested. It's preparing to build 3 of them. One that configures DHCP server functionality, one that configures DNS server functionality, one that configures domain controllers and network policy servers. NPS is the feature that's going to govern things like VPN functionality. You might still have dial-up capability out there, that sort of thing. Clicking Apply, we will have finished the provisioning process, which really is just telling IPAM which of those 2 strategies we're going to deploy. So it's doing its work behind the scenes to get itself ready for one or the other of those approaches. And there we go. So that finishes the provisioning process. It has configured the set of data that it needs to be able to build the GPOs, but interestingly, it has not built them yet. It has defined a set of security groups on the IPAM server to be able to describe who gets access to IPAM. Again, that's very important if you're connecting in from some other client computer. Being a part of the right IPAM management groups is very important from that perspective. That being said, we can click Close. We've finished phase 2 of our IPAM setup. Phase 3 is server discovery. I want to tell IPAM what part of my AD infrastructure this is designed to support. And I can manage multiple domains as long as they're part of the same forest. I cannot support multiple forests with IPAM, but I can support any number of domains in the same one. In this case, the globalmantics.local domain is our domain, and I get my choice of which kinds of servers I want to hunt through Active Directory hunting for. Domain controllers, DHCP servers, DNS servers, and I get my choice. I'm going to turn on all three. I don't see a reason why not. But if I wanted to focus my deployment of IPAM to particular kinds of servers, if this was just a DHCP management effort, I can limit my focus if that helps. That, of course, limits the amount of data that's gathered into my database. Server discovery is configured. Step 4 is to actually identify individual servers. Now that we know what domain we're searching in, I click Server Discovery, and you'll note that it starts the process of running a task in the background. It slid my screen over, but you can see a little yellow message there that tells me that one or more IPAM tasks are running in the task scheduler. Server Manager accomplishes a lot of what it does by handing off jobs to Task Scheduler to be run behind the scenes. It's a wonderful technique, and it really automates a lot of good stuff. You can watch, if you're feeling really bored, up here. I click that little flag, and it shows me what tasks are still in operation. It's doing an IPAM server discovery, and when that completes, we'll be able to see which servers the discovery process has detected. And there we go. We've successfully completed our installation. We've completed our server detection. So our next phase is to go look and see what we found. Step 5 here, select our Add Servers. Will jump us to a screen in which we can begin to see that we have detected a server called New York City Server 1. Hey, how about that? Its manageability status is unspecified. The system found the server, but doesn't know whether it should manage it or not. It's in a kind of a neutral state where it says, hey, I see a server there, but I'm not sure, Mr. Administrator, if you want me, the IPAM server, to handle that. So what we can do to be able to change that is to pull up the properties. We're going to edit the configuration of this server. And the thing to do is to change its manageability status to either unmanaged, saying, I don't intend to configure this. This is somebody else's project. I'm going to leave it alone. Or managed. I want IPAM to take over responsibility for making changes over this particular server. In this case, I'm not going to make any change. I'm going to leave it as is and cancel. We will come back to this screen. But what I want to do first, at the moment, I want to draw your attention to something that's more important than the unspecified manageability status, and it's the IPAM access status. And at the moment, you can see that IPAM says that it is blocked from being able to access this server. If I scroll down below, I can see that the IPAM's access status is in fact blocked, and it says that that's in part because DHCP access is blocked, DNS access is blocked, event log access is blocked. That's important for domain controllers, for DNS, for DHCP. So it's saying, hey, I can't get into that computer. And if you think back just a moment ago, we realized that we created a description of some GPOs that we wanted to deploy, but we never did. In order for that to work, we need to run that IPAM PowerShell commandlet that we identified a moment ago. So let me go launch my PowerShell console here on Server 2. So here in my PowerShell window, I'm going to run the magical invoke-IPAM GPO provisioning commandlet to be able to configure my environment in preparation for its work. Now, one interesting thing about PowerShell in Windows Server 2012, we'll address PowerShell in some more detail later, is that I'm no longer required to import the module that contains the commandlet that I need ahead of time. PowerShell will see me type something that looks like a commandlet. It'll go search the available set of modules, looking for one that contains my particular command that I'm issuing. So I can just go say invoke -IPAM GPO, and I can even take advantage of tab completion here. Say, hey PowerShell, I've typed enough. You do the rest. Go look for a commandlet that starts with that set of characters. Now, if you're not familiar with how to use a commandlet of this sort, you can always prefix it with help. PowerShell will gather for you the set of information that describes the command that you're about to issue. For our purposes, we need about half of the available parameters that are available to my invoke-IPAM GPU provisioning syntax diagram there. But let me go ahead and invoke this with some of the most commonly used options. I do want to specify the domain for which I'm setting this up. This is globalmantics.local. Within that, I do need to identify which IPAM GPO prefix I want to use. That is GLBM. Following which, I'm going to specify which IPAM server I want to use. And that's the only IPAM server that I've got at the moment, which is New York City Server 2. And I want to specify which delegated GPO user is going to do the work of reaching into my domain and configuring the GPOs that are necessary to make this work. Delegated GPO user I'm going to use is administrator. Everything else we can leave off for the time being. We're in good shape there. System wants to know, am I sure I want to do that? Pointing out that this is a fairly important change. Am I sure I want to do that? Yes. This is what's sometimes referred to as a high impact change, which is why it's prompting me. I could have used the -force option if I had wanted to get around the prompt. So behind the scenes, it just built a bunch of GPOs, and that is nearly done. And there we go. So that's now all set. Let's confirm that. Let me jump back over to server 1 and take a look at the GPOs that this commandlet built for us. Because it'll be important to understand exactly what's happening there, to understand some of these I'd say somewhat strange behavior as IPAM gets ready to begin working with a new server. So let me minimize my connection to server 2. Here I am back on server 1, and I'm going to go to my Group Policy Management console. Inside of which I'm going to browse down into my forest. From there into my list of domains, I've got one domain, globalmantics.local, and look at that. There are 3 GPO links. I'm going to turn off the "Are you sure you want to manipulate a GPO?" nag screen. GLBM, DC, NPS, domain controllers, network policy servers, DHCP servers, DNS servers. 3 links to 3 GPOs. Of course, they live down here in the group policy objects container, as any well-behaved GPO should. Those 3 links are tied to the domain. We can see that here. We can see it over here off to the right. And something rather interesting might catch your eye if you've got some background in managing group policy. You might notice something that seems odd. What should strike your eyes as odd is this area here in the lower center. This area contains the permissions list of which users or computers are allowed to apply the GPO to themselves. In general, we tend to see in there something called authenticated users, identifying that everybody has permission to apply this to themselves. And at the moment, there's nobody in the list. Well, that's a tad bit surprising. The GPO is attached to the domain, but no one has permission to use it. And what effect does that have? Well, by way of demonstration, let me jump back to the command prompt here on server 1. And in my command prompt, I'm going to run a couple of group policy management utilities. Some of them you're probably familiar with. First, I'm going to run GPUpdate. GPUpdate has the ability to retrieve recently updated group policy objects and apply them. I'm going to use the very popular /force switch. /force ensures that we apply changes even if it seems to the group policy engine that they haven't changed. Ordinary group policy application only applies settings that appear to have changed. /force says go get everything, reapply all settings even if they don't appear to have changed since last time around. It's kind of a nice double check. It doesn't add much time. So I've applied my changes. Let me do a GPUpdate, or let me do a GP result /R. I want a basic report describing what group policy functionality this computer believes it's under the influence of. And specifically, I note that all of my GLBM GPOs are being denied. We're not applying them to this server, even though I really want them to. And it says the reason why is security. It says it's not applying that because it doesn't have permission to apply, which kind of jives with what we saw over here in the Group Policy Management console. At the moment, nobody has permission to be affected by these GPOs. This GPO affects not a single soul. How do we fix that? Why would we deploy a set of GPOs that nobody's able to use? Well, this is part of the cleverness of the IPAM design. Let me jump back over to Server 2 for a moment. And on Server 2, I'm going to configure IPAM to change the manageability status of Server 1. And I'm going to change it from unspecified to managed, which is a way of saying that I want IPAM to be in charge of gathering information and reacting to this server. So I've changed the manageability status to managed to be able to tell IPAM this is a server that I want to be able to be managed by IPAM. How does it make that happen? How does it turn on the ability for it to be managed? Remember that management from IPAM comes from the ability to access a server by way of getting through the firewall in certain ways, being members of certain server groups, things of that sort. We just told IPAM, yep, this computer wants to be that way. Well, we've got a set of GPOs that are designed to make that happen, but nobody had the permission to access them. We just turned on manageability status for Server 1. It would make sense if that reached over to the GPOs and turned on access for those servers to access that GPO. Let's see if it in fact did that. I'm going to jump back over to Server 1. So as I click each of these GPOs, we note something rather interesting. Each of those GPOs has New York City Server 1's computer account, NYC Server 1 $, in the list of GPOs that have permission to read and apply that GPO. That means that that server and that server only is affected by this set of policies. So that's really rather clever. IPAM is using the permissions management structure of group policy to make sure that only the servers that we want managed by IPAM will receive the firewall changes, the group administration changes necessary in order to let that happen. There's no need to apply those settings to servers that aren't going to be managed by IPAM. It's a nice benefit. Having done that, let's jump back over to the command line tool here on Server 1. So back here on the command prompt, I'm going to rerun the GP update to be able to reapply the configuration settings that we just got done configuring permissions for by way of the IPAM console. And having done that, I'll then do a rerun of my report to be able to validate that the configuration settings in fact applied successfully to this server. Something that's an easy thing to get scared about, turns out needlessly, is the deny messages here. Uh-oh, this GPO was filtered out. It was denied. The security settings. Uh-oh, what did I do wrong in security? It's tempting to start flailing and start adding all sorts of permissions to the GPO needlessly. Not necessary. Turns out that all the configuration settings in the GPO are on the computer configuration side of the GPO. And it's the computer configuration side that we care about. What we're looking at here is the set of user settings. If I scroll further up, we can see that on the computer configuration side of the house, GLBM DNS, DCNPS, DHCP on the computer configuration side are all being applied. Those are applied GPOs. As such, they are going to be perfectly able to be taking effect on this server, which means if I jump back over to IPAM, I should be able to see that server move out of the blocked state and into the manageable unblocked state. Let me jump over to Server 2 and we'll confirm that. So here I am on Server 2, and if all goes really well, we throw a quick click at our refresh button, and we see the manageability status change. In my practice, it doesn't seem to happen as quickly as I would like, so what I tend to do is I like to take a step to go back and rediscover the servers. I trigger a rediscovery process. Remember that discovery was part of the process available here in this overview screen. So I'm going to start a new server discovery. Worth pointing out that that happens periodically anyway. If I didn't do this personally, the system would automatically do it after a certain period of time, and eventually we would see that status change. I'm just being impatient. And your time is valuable too, so there's no point in waiting around for that to happen for 10 minutes. So it is behind the scenes doing its server discovery. When that completes, we should be able to see a working, unblocked copy of our server. And there we go, we've completed our discovery task. So I can, at long last, retrieve data from those managed servers after I've confirmed the server that I'm looking for is in fact there. And if I have to refresh, There we go. We have an unblocked, manageable server. Let me go retrieve data from it. I can do that from the overview screen by choosing to retrieve data from managed servers, or back here in my server inventory window, it shows me my list of computers that I'm managing. Alternatively, I can go here to the tasks pane and retrieve server data. That's going to reach out to those computers and gather everything that those servers know, which is potentially quite a bit of information. We're going to look at our DHCP servers, see which addresses have been assigned to whom. It'll gather event log data from DNS and DHCP, address utilization, what fraction of my IP address ranges on my DHCP servers are being utilized. This may provide me with targets for reclaiming addresses that I don't need and applying them somewhere else. Those are all interesting possibilities that are enabled in part by the nifty database-driven solution we're looking at here. All right, so we have gathered information about our server. We know what it looks like. I want you to again envision here not one server. Managing one server that's a DHCP DNS server is as good as managing any one other server. But I want you to consider the possibility that we might be managing not one, not a dozen, indeed maybe 100 DNS and DHCP servers across a national-sized organization from one central console. Imagine the challenge of trying to coordinate what's happening on dozens of DNS servers and dozens of DHCP servers without recourse to some centralized database of what's out there and how it works. This is a big step in the right direction, and one that's going to provide some really rather substantial ease of your own peace of mind, giving you the ability to understand what your network is doing, which IP addresses are out there, and what they're doing. So our next big task is figuring out what to do with our address space. We've got a range of addresses available to us. We've got maybe several ranges of addresses. I want to be able to keep track of what they are and be able to use them wisely. This is where IPAM really shines. It's designed with the idea in mind of trying to allow you to make your IP addressing scheme really fit the way you want to manage your network. There's a variety of ways to be able to organize the information that's in IPAM, to be able to sort and organize by characteristics that match real-world categories of information that your organization cares about. Maybe you manage your IP address scheme by country, and in different countries you're doing things differently. Maybe you don't think about countries too much, you think in terms of regions. You think of which continent is it on, or particular sub-collections of territories around the world. You might think of things in terms of regional internet registries, RIRs, those 5 large entities that manage IP address assignment in the world. Those are all lie under the authority of the Internet Assigned Numbers Authority. IANA.org is their website if you're curious about how they apportion the IP address range across the worldwide network. However we choose to deploy our particular part of our IP address scheme that we get from IANA, from our RIR, the goal of IPAM is to give us a way to be able to manage that in the way that makes sense to us, rather than forcing us to do things in a way that makes sense to whoever wrote the software. So it's a very flexible piece of software, as we're going to see. So we're going to be able to design our addressing scheme and be able to report on which IP addresses are being used by whom and when. So back here on Server 2, I want to start exploring some of those pieces of functionality. We've got an area here on the left, a node labeled IP address space, which provides some textual description of what IPAM thinks about. I invite you to stop and read that at some point, not just at the moment, though certainly you could pause the recording and take a perusal of that. That's not a crazy idea. What it's pointing out here is that we've categorized our address space into 3 major hierarchical categories, where at the top of the food chain is something called IP address blocks. An IP address block is designed to describe, for example, the major collection of IP addresses that we requested from the Internet Assigned Numbers Authority when we wanted to make our organization Internet accessible. So we go to our ISP, or we go to IANA directly, we say, hi, we're a large company, we need a Class B address range. What can we do? There was a period of time where IANA would service that directly. They now, of course, do that principally through ISPs. But anyway, I get a block of addresses that I can deploy within my organization. I want to describe that in such a way that I can then logically partition that into chunks of addresses that I can assign to individual DHCP servers. So, with that idea in mind, let me build a range of addresses. Now, you note something interesting here. It's already detected an IP address block, or more correctly here, an IP address range that corresponds to the scope that I created on the DHCP server at NYC Server 1. That's kind of nifty. It's using dynamic assignment. It is using DHCP to deploy addresses to clients that want those addresses. Neat. We'll deploy more IP address ranges in a minute, but let me jump to address blocks. The blocks are the logical top of the hierarchy, in which I can create new IP address blocks from my tasks list. So I'm going to type a network ID just kind of randomly off the top of my head, 177.82.206.0. And that will cover a Class C address range. It's going to offer me a subnet mask for that of 23 bits. I'm going to make it 24 for nice round numbers. There we go. Range of addresses from 0 to 255. Which RIR did I get it from? Again, there's my 5 regional internet registries. Africa there, Asia and the Pacific. ARIN is the Americas regional internet networks provider. Latin America and the Caribbean, LACNIC. RIPE is Europe. There's a fancy French phrase that those initials represent, and I won't torture you by trying to pronounce that in French. The first word, réseau, means network. So European IP network is what that essentially means. Okay, I did give you a little bit of horrible French pronunciation. Sorry about that. So when did I get this from the Regional Internet Registry? I can describe that. When's the last date I assigned an address from it? I can assign that. I can specify an owner. Who's in charge of managing this? I'll say it's me. Description. This is the, let's see, public address block for the new Dallas office campus we're deploying. We've got 18 buildings in an office campus. I want to describe that here. That becomes part of my IPAM database. And later on, when it comes time, I just got a range of addresses for Dallas from Europe. That doesn't seem terribly likely, does it? That should probably be ARIN, shouldn't it? Is that important? Not really. But really, a lot of these fields are mostly meant for descriptive purposes. I can do queries later against this database and find out information and spot patterns in the way things are working because I've provided adequate descriptions of what's in my network and how it works. So there's an address block. Under the general heading of address blocks, we then have address ranges. We saw an example address range here in our range coming from our own DHCP server, but I could potentially create others. I can define additional address ranges specifying what network ID they use. Let me use a subset of the addresses inside of the new range that I just got done creating. Let me go back and pull up my randomly generated one. So under the general heading of my 206.0 network, let me create a small network inside of that, an address range that's going to use a network ID of 177.82.206.0, and I'm going to use not a 24-bit, but maybe a 27-bit subnet mask here. So we're deploying just IP addresses 1 through 30 out of my range of 255. This is going to be a small office building. It's got 20 employees in it. So we've got a couple IP addresses for routers. We're good. Am I automatically assigning address values? Yes. Who's going to manage the service? IPAM itself, some non-Microsoft DHCP server. In this case, I'm going to let it be IPAM. Which service instance are we talking about? It's the one here on this local server. What kind of assignment am I using for those addresses? Well, we're going to use dynamic addressing. I want to be able to use DHCP to hand out addresses. I could alternatively have left that as static if I wanted to. That range of addresses I'm carving out for manual assignment. So these are clients in Building 7. Who's responsible for that? Penny is responsible for managing those. Penny's my network assistant in that local office. Having configured all that, I click OK, and we've described that particular address range. My system now knows that there is a range of addresses designed to support our Building 7 staff, and there's that range of addresses right there. Neat. This is logically contained within the address block, so I can track address blocks. Instead of address blocks, I've got address ranges. Inside of those address ranges, I've got individual IP addresses. I can see individual addresses Don't have any configured at the moment, but let me create one. Let me specify a specific address. Now, I'm not showing the list of addresses that have been gathered by a particular DHCP server, the address assignments. What we're doing instead here is identifying addresses that I want to configure for somebody. I want to assign a particular IP address. Let me pull another one from my range that we were just looking at a moment ago. Let me cancel and bring that back up after I can see what I'm doing. So I've got a range of IP addresses I want to deploy from this top one. I want to create an address for somebody in building 7. And let's see, that IP address is going to be 177.82.206. And I'm going to assign the .1 address. And the MAC address I could specify if I chose to. Let me imagine one. AB-CD-EF-01-02-03. Capitalizes it for me. Who's managing it? IPAM is. Which one? The one on the local host. What kind of device is this? Well, maybe that's my router. How's it being assigned? It's static. Somebody's going to manually configure the router. I don't want DHCP to deploy that, but I want to record the fact that I've set that IP address aside for that purpose. Description. This is the local office router. Who's in charge of that? Penny's in charge of that because that's in building 7. Down below that, if I wanted to make this something that is deployed via DHCP, I could say so. I skipped over a couple things. Asset tag, serial number, this is a device. I might describe exactly which device it is and have that in my database. I can search for it later. DHCP reservation info. If this address is going to be assigned by DHCP, I can say so. Identifying that I do intend to make it available, I can specify what the name of that reservation is, what type of reservation, what type of server is it designed for. Historically, of course, we've used DHCP, but DHCP is itself an extension of an older protocol called BOOTP. So in this case, I'm going to say both, just for safety's sake. Specify a description for that reservation, some piece of text describing why I chose to build it. Again, the importance of documentation is embedded in the nature of the tool itself, which is really rather nice. Down below here, I want to specify, do I want to put this in the DNS database? In many cases, yes. In the case of a router, probably not. That's not a terribly important thing to resolve. We're going to be configuring router addresses directly by IP, probably through our DHCP server options or scope options. But in the event that I wanted to, I could pick which forward lookup zone in my DNS server I wanted to record something within. There it is. Which server do I want to target that request at? Again, a friendly name for that device for the purposes of the DNS record. Now in this case, I'm going to leave that alone. I don't really intend to do that. But having put all those pieces together, it's going to be persnickety here because I've already started filling it in. It wants to know what the name of the device is. That's fine. This is the Building 7 router. Having done that, it will now let me click OK to be able to commit that change. I've added an IP4 address to my database. Now, if it seems like a lot of work to add one of those, it's worth pointing out that I can import that data by way of reaching out to a CSV file. Documentation from Microsoft defines the particular shape of the CSV file that the system wants to retrieve, but I could go target this at that file and say go bring in all of the IP address data that I've gathered in my Excel spreadsheet. I just need to rearrange it into the format that IPAM expects, and suddenly, poof, I can import all that data I've been tracking in my whatever it was, Access database, clipboard, whatever. If I turn it into a CSV file, I can import it directly into IPAM all in one fell swoop. Neat. That is IP address space management. It's a wonderfully full-featured function. Let's shift gears and take a look at the other important feature of IPAM. The other important feature being multiple server management. What do I do to deal with the fact that I've got multiple DHCP servers? What do I do with the fact that I've got multiple DNS servers? How do I keep track of how many of these things there are, configuring them appropriately? It would be easy to lose track of which servers are located where, which server is that feature located on, how do I get connected to it, unless I had one central spot with access to all that information. Well, it turns out that's what IPAM is designed to do as well. So let's turn our attention to that for a moment. So back here on Server 2, I'm going to turn my attention to this region over here on the left, monitoring and managing. Monitor and Manage is the name of the section, within which 4 broad collections of stuff. DNS and DHCP server functionality lets me see my list of DNS and DHCP servers. I've only got one of each in this particular example, but again, I'd like you to envision dozens of them in there. For any one of which, I can right-click that server and be able to configure it live from here, from one central console. My DNS server, I right-click it. Do I want to launch my MMC console? Sure. And there I am live effectively on the New York City Server 1 DNS server, able to do all of my DNS configuration as if I had just sat down in front of it. In a similar way, I can right-click DHCP, but being this is designed for IP management, we've got better integrated functionality. I can directly go build a DHCP scope from here. I can launch the MMC. I can just pull up information about my DHCP server's properties. You'll recall earlier we configured our options for name protection. We talked about configuring options for a variety of additional pieces of data. Do I want to do auditing, things of that sort. I can apply all these changes from a central console. Behind the scenes, IPAM reaches out to that server, performs the configuration from here. I don't even need to go visit that server. I can trust that IPAM did the work of configuring that information for me. Wonderful opportunity. I can go browse my existing set of DHCP scopes. I can see that I've got a scope called the GlobalMantic scope running from 172.18.0. something, or we've got a range of addresses that are currently utilized to a 77.69%. That is an underutilized scope. We would see that shift to overutilized if it got above a certain threshold. I can see where that server is. I can see that it's running adequately. This looks good. If I throw a right click at it, I want to configure the details of that scope. I've got access to that from right here. And there's our IPAM scope configuration window, in which I can see the name, the range of addresses. Maybe I want to change my lease duration. Maybe I'm getting ready to phase out this DHCP server and bring another one online. So I'm going to cause these servers to stop refreshing their IP addresses every 8 days, and instead I'm going to have them start retrieving updated IP address leases once every 5 minutes. Because what I'm going to do is, once the computers are all cycling every 5 minutes, I'm going to decommission this DHCP server. After I brought up the other DHCP server, 5 minutes from now, that computer runs out of lease on its IP address, shouts, "Help, help, I can't get an IP address," and gets one from the new DHCP server. And I can do that without ever setting foot in the office where that DHCP server resides. Wonderful option. DNS configuration settings in DHCP, we're familiar with those. Scope options, we saw some of those. I can configure a DNS server address. I can configure a Win server address. So all the configuration details that used to require a trip to that network, or to at least go try to figure out how to fumble my way into the MMC for that tool, can all be done from one centralized console. Wonderful opportunity. This is a great benefit to the administrator. I can monitor my DNS zones in the same way I can monitor DHCP scopes. I'll see that my zones are in a healthy state. If I would right-click one of those zones, I can retrieve a new zone status and verify that it's still working correctly. I can retrieve that same command here from my task list, retrieve server data. And I can organize data into server groups. I can logically categorize servers by way of a variety of interesting properties that it might be of interest to me. Down at the bottom, event catalog. This is my forensics data. I want to go look at what events have occurred on the IPAM server itself, what has happened in DHCP's world. I want to go track usage of IP addresses. I want to see, I've got a Windows 8 client out there. I want to see what has happened with IP addressing on the computer whose name is Windows 8 client. And specifically what has happened on that computer and the dates between, and let me just pick a wide range of range of times. Let me say, let's see, month, day, year. Let's go January 1st of 2007 through December 31st of 2017. That's a fairly broad range, but it'll do. It's going to go consult its database, and sure enough, it sees that this computer got a new address lease at 9:54 in the evening on the 28th of January in 2013, and renewed it. But looks like the next day. Yep, cool, very good. I can do analysis of forensics on IP addresses by IP address. I can watch an IP address and see where it wandered to if it traveled from one computer to another. I can go the other way and look by username. This user, which IP address or IP addresses did this user have when logging in? How does it know that? It consults the domain controllers. It knows when users have logged in. It correlates that against the data that the DHCP DNS servers gathered. Remember that this functionality in part rests upon your configuration of option 81, the option to have the DHCP server take responsibility for updating both the A and PTR records for clients that wanted to register their DNS data with DNS. So that's I want to kind of logically complete the loop there. That's an important consideration that we addressed way back in the section on DHCP, but here it is coming around to us again. So there we are. We've made it to the end of the IPAM discussion. This is a wonderful feature that will be able to improve your ability to manage IP addressing throughout your organization, taking a potentially national or worldwide IP addressing regime and standardizing the description of it onto one server where you'll be able to manage that and have the peace of mind of knowing that everything is accounted for in a way that makes sense. Thanks for being a part of this lesson. I look forward to delivering the next one to you.